In October 2017, an observer at the Pan-STARRS telescope in Hawaii noticed a faint speck of light moving with impossible speed across the sky. It wasn't a local asteroid, and it wasn't a comet from our own Oort cloud. For the first time in human history, we were witnessing an object that had traveled from the vast, empty darkness between the stars. It was named Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. But as the world's most powerful telescopes turned toward this visitor, the excitement turned into a profound, unsettling mystery. Oumuamua didn't behave like any rock or ice ball we had ever seen. It was tumbling through space with a strange rhythmic pulse, and its shape was unlike anything in our solar system. Extremely elongated, like a dark metallic cigar or a thin, flat disk. The more data we gathered, the more the traditional labels began to fail. It had no comet tail, no dust cloud, and no gas. Yet, as it rounded the sun and headed back into the abyss, it suddenly accelerated. It was being pushed by an invisible force that gravity alone could not explain. Was this truly a natural object? A piece of cosmic shrapnel from a distant star? Or were we looking at something far more intentional? As Harvard astronomer Avi Loeb famously suggested, we may have just witnessed the first piece of extraterrestrial technology to enter our neighborhood. Today, we explore the 5 chilling reasons why Oumuamua might not be an asteroid, but a scout from another world. When astronomers first calculated the light curve of Oumuamua, they realized they were looking at an object that defied every known geometric norm in our solar system. Most asteroids and comets are somewhat spherical or chunky, but the way Oumuamua's brightness fluctuated, changing by a factor of 10 every 8 hours, suggested an extreme shape. It was at least 10 times longer than it was wide. Initial artist impressions depicted it as a long, cigar-shaped rock, but further mathematical modeling by researchers suggested an even more radical possibility. It might have been a thin, flat, disc-like object. Such an extreme aspect ratio is virtually unknown among natural space rocks, leading some to wonder if its geometry was engineered for a specific purpose rather than formed by random collisions in a distant star system. Beyond its shape, its velocity was equally baffling. Oumuamua entered our solar system moving at nearly 60,000 miles per hour, coming from the direction of the star Vega. However, Vega was not in that position when Oumuamua was there hundreds of thousands of years ago. In fact, Oumuamua appeared to be stationary in the local standard of rest, a kind of cosmic parking lot where the average velocity of stars in our galactic neighborhood is 0. It is statistically rare for a natural object to be found in this state of rest. It's as if Oumuamua was a buoy floating in the middle of the ocean, and our solar system simply crashed into it as we moved through the galaxy. This lack of a clear home trajectory suggests that Oumuamua didn't just get kicked out of a nearby planetary system by accident. It may have been waiting in the interstellar void for eons, a silent observer, or a dormant piece of technology, until our sun's gravitational pull finally drew it into a brief, high-speed flyby of our world. The most controversial moment in the Oumuamua timeline occurred as the object began its journey out of our solar system. As it moved away from the sun, it didn't just slow down under the pull of gravity as expected. Instead, it showed a clear, distinct, non-gravitational acceleration. In simple terms, something was pushing it. Normally, when a comet speeds up like this, it's due to outgassing. The sun heats up the ice, creating jets of gas that act like rocket engines. This process creates a visible tail, or coma, which is the trademark of every comet we've ever observed. But Oumuamua was different. Despite the most intense observations from the Spitzer Space Telescope, there was absolutely no sign of dust, gas, or carbon-based molecules trailing behind it. There was no jet to provide the thrust. Furthermore, if outgassing had occurred at the level required to move an object of that size, the force would have caused Oumuamua's rotation to change drastically, likely tearing a natural rock apart. Yet, its spin remained steady and rhythmic. This left scientists with a mathematical crisis. If it wasn't gas, what was the force? The acceleration was smooth and followed a specific one over R-squared law, which is exactly how light pressure behaves. This led to the staggering realization that the only natural force left to explain the movement was solar radiation pressure. But for sunlight to push an object that fast, Oumuamua would have to be incredibly thin, less than a millimeter thick, and massive in surface area. In the world of physics, such a structure doesn't occur in nature. It is the exact description of a light sail, a piece of technology designed to travel between stars, using nothing but the momentum of photons. While many astronomers tried to fit Oumuamua into traditional boxes, a group of scientists, led by Harvard's Avi Loeb, argued that the evidence pointed toward a technological origin. Here are 5 specific reasons why this visitor defies a natural explanation. First is its unusual reflectivity. Detailed analysis of the light bouncing off its surface showed it was significantly brighter than the average asteroid or comet. It possessed a shiny, potentially metallic quality that suggested a polished surface rather than the dull, porous rock we expect from cosmic debris. Second is the thermal anomaly. When the Spitzer Space Telescope attempted to track the object's heat signature, it found nothing. Oumuamua was much cooler than a rock of its size should have been after passing so close to the sun. This suggests it was made of a material with high thermal conductivity, or perhaps it was hollow. Third is its perfect trajectory. Oumuamua performed what looked like a calculated gravity assist, dipping into the inner solar system and passing close enough to Earth for a high-resolution snapshot before exiting. It entered the habitable zone with suspicious precision. Fourth is the extreme geometry. Nature rarely produces objects that are 10 times longer than they are wide. However, this is a perfect shape for an interstellar craft designed to minimize damage from gas and dust in the interstellar medium. Finally, there is the light sail evidence. As we explored, the only force that can explain its acceleration without a comet tail is solar radiation pressure. For this to work, Oumuamua would need to be a thin membrane-like structure. Professor Loeb argues that we may be looking at space junk from an advanced civilization, perhaps a discarded sail or a defunct sensor buoy. Just as our own Voyager spacecraft will eventually wander into other star systems as dead tech, Oumuamua might be the first piece of another world's history to drift into ours. If it was a probe, it was a masterfully designed one, silent, efficient, and long gone before we could even ask where it came from. The departure of Oumuamua from our solar system marks one of the greatest missed opportunities in the history of science. By the time we realized that this visitor was truly anomalous, it was already moving too fast for any current human spacecraft to intercept. We were left standing on the shore, watching a mysterious vessel disappear back into the vast, dark ocean of the Milky Way, likely never to be seen again. Whether it was a bizarre hydrogen iceberg or a discarded piece of alien technology, Oumuamua has permanently shifted our perspective on the neighborhood we inhabit. It has forced us to accept that the interstellar void is not empty. It is a highway of travelers we are only beginning to detect. If Oumuamua was indeed a scout or a piece of advanced space junk, it proves that we are not the only ones reaching for the stars. It serves as a silent, haunting reminder that the universe is far older and more populated than our current maps suggest. As we build more sensitive telescopes and prepare for the next visitor, we must remain vigilant. The messenger has passed, but the message is clear. We are no longer alone in the dark, and the next discovery might change everything we thought we knew about our place in the cosmos.